All right, so that handout I gave you is going to be something that I want you guys to keep. I also emailed you a PDF of it. If you lose it, you need to print it off again. I would say every time you do a proof in here, especially early on, homework, test, quiz, have that next to you. Okay. On tests and quizzes, I will provide one, but I want you to have some guidance to help you get through them. Okay. There's no math guidance there. Does that kind of make sense? It's more structure. This is how I'm going to go about writing a proof. That should help. Okay. Proofs, by definition, are convincing arguments that use deductive reasoning. All right. To make a strong argument, you must have no gaps in your proof. Okay. So what we're going to do is we're going to kind of go back to that courtroom idea. Okay. If we're trying to hold a trial for somebody, let's say Johnny's a Grand Theft Auto. Okay. Got in trouble for stealing car. Okay. That's what we think he did. If he's got a really good lawyer, and his lawyer says all this stuff about Johnny and shows that he probably did not steal this car, beyond a reasonable doubt did not steal this car. But Johnny's lawyer is unable to validate where Johnny was at the time that the car was stolen. Is that a gap in Johnny's lawyer's argument? Yeah, and the prosecutor is going to find that gap. They're going to attack that. They're going to make sure the jurors know this is an issue. Okay, if nobody knows where Johnny was from 1:30 to 2:30, and the car got stolen at 2, nobody knows where Johnny was, and nobody can validate it. Nobody can say I was with Johnny at that time. That's a problem. Okay, when we do mathematical proofs, we're kind of the defense attorneys. We're Johnny's lawyers. Okay, and we want to make sure that we write an argument that Math Excel, Mr. Fay, or the end of course exam graders, or just general the math community, cannot attack any of the gaps in our proof. Does that make sense? So we're defending why something is true, and there cannot be any holes in that. All right. A proof logically shows why a conjecture is true. Okay. I say conjecture, we're talking a conclusion or a statement. Okay. That last bolt there is the idea here. This is the deductive reasoning aspect of it. If my last statement is D, and I want to show that that is true, it can only be true because the statements A, B, and C that came before it were also true, right? Okay. If any of those were false, there's no way D could be true. Okay. So that's the deductive reasoning. That's the law of syllogism, law of detachment aspect going into that concept. Okay. So that gets us to this. Okay, you don't have to write this down. But all the proofs that we go through, guys, this is the structure for it. Okay. When you guys write a paper in English class, what is the first thing that you do? What's the first thing you write when you try to construct a paper in English class?
My name.
You write your name, you write your title. But your title and your name should probably be written somewhere else, right? Not in the
body.
Well, not in the body paragraph. Say again? Okay, you got your introduction, but these are all components of your paper that you're going to submit, right? That you're going to turn in. What are the things that you do in preparation of creating that one that you're going to submit, turn in? You create a rough draft, would you say? You say outline? Yes, you did.
Yeah.
Okay. So outline, rough draft, right? Okay. So these proofs that we're going to do, they're kind of that. They're an outline or they're a rough draft. Because when we're done, like in a rough draft, when you're done, do you ever go back through and say, I didn't need that sentence, let's take that out? Or it's better if sentence 3 replaces sentence 5, or sentence 5 replaces sentence 3. Does that kind of make sense? Kind of reword things maybe. Maybe add some extra information that might be vital. So when we do a proof, we're kind of doing the outline. If we need to, if we want to, when we're done, we can kind of finalize that and make it prettier, make it nicer. Okay? A lot of times what we like to do is we like to take that outline and write an actual paragraph, a mathematics paragraph that shows the proof. And it's really easy to do that once we have the outline. Okay? If you can use transitional words like there and thus and therefore, and in addition to that kind of stuff, you're going to be okay with transferring these things in the paragraph. But this is our outline. This is going to be kind of the best way right now for us to do a proof. Okay? All of them are going to look like this. So you're going to be given what we call a given statement. Okay? It's a provided statement. And ultimately it boils down to that is the if statement. It's the hypothesis of some conditional statement. Some other conditional statement that we're trying to prove. That's the if part. Okay? The prove part, if the given is the if, it's the hypothesis, and the prove is probably the, if the given is the hypothesis, then the prove is probably the conclusion. The prove is the conclusion of our if-then statement. Okay? Now, the reason I discussed that and talk about that, and we'll come back when we need to use that idea later on. There'll be times in class where I give you a conditional statement. Let's say that if you have an isosceles triangle, then base angles are congruent. Okay? That's an if-then statement, right? If I ask you to prove that, that's all I said, prove this if-then statement. You need a given, you need a proof. Well, the given is the isosceles triangle aspect. It's the hypothesis. The proof part is then, well, I got to go through and show that base angles are congruent. All right? So if they ever give you just a phrase to prove that is an if-then phrase, and they don't write it like you see up there in front of you, then you got to take it apart, and you got to determine that your given is your if part, and your prove is your then part. Okay? There's always going to be a picture. I don't want to say always. 99% of the time there's going to be a picture. And that picture is very useful to us. You've heard the phrase, a picture says 1,000 words, right? Okay? So, we're going to have a lot of words up here. We're going to have a lot of algebra up here in front of us. But that picture is going to be very beneficial in regards to how we structure those words and how we structure that algebra. So we need a picture, okay? And we're going to adapt our picture. We're going to continually add to it as we move through the proof. The things in the columns, okay, the statements. Okay, the statements are going to be things that we are able to say are true. Okay, so here we know that angle 1 is equal to angle 3. That's true because it was given to us. Okay, so these are algebraic or geometric statements that we're going to kind of fill in. If you read these, it says each statement should follow logically from the previous statement. Here it says the last statement is what you want to prove. Last statement should be that. Okay. Now, we don't know that when we do a proof, when we set out to do a proof, we don't know it might take 5 steps or it might take 6 steps. We don't know the final conclusion of how many steps it's going to be until we get done. Okay. So even though that one says we finish at 5, it's just kind of an example that this one finished at 5. Okay. It could have been 6, 7, whatever. So these are algebraic or geometric statements over here on the left, and these are the why or the because of statements on the right hand side, the reason. Does that make sense? So maybe the next one I say that as we do this proof, we'll do this proof here in a little bit. I might look at that angle there and say, well, that angle, that purple angle, is made up by angle 1 plus angle 2. Would you guys agree with that? Well, the reason for that is the angle addition postulate. And that's the why I know 1 plus 2 equals that purple one. Okay? So we'll put the reason, and that's what we're kind of trying to target yesterday with that homework assignment. With a lot of those questions, looking at a if-then statement or 2 lines of work and say, okay, what was the reason that allowed to go from the first line to the second line? Maybe it was the distributive property, maybe the reflexive property, the symmetric property, or addition property. Those properties, those definitions, those other postulates are going to be all on your reason side. Okay? So the why of something. Okay? And we jam all that stuff together, have a bunch of statements, and then the valid why of why those statements are true. And if they're all true, then that last one has to be true. And we've effectively then proven our goal that we set out on. Okay. Now that handout I gave you, it is going to be useful for you in regards to if you're going to do a proof that you have to do 100% on your own. Okay. Because that will be the situation eventually. But we're going to start off kind of holding your hand or kind of pulling you through the proof to help you out a little bit. I'm not going to hold your hand. So if if they walk you through the proof by providing you some statements, and sometimes they'll fill in the reasons as well. Basically, what the author has done is they've done the proof, completed it, and then they go back with whiteout and erase some statements, erase some reasons, and that's how you're going to see them initially. When that's done, the author may not have used the same steps that I have laid out in front of you on that worksheet or that handout. They should be similar. They should be pretty close, but they might not be verbatim. Okay, that set of steps I gave you is not set in stone. It's not. You're never going to see that in a textbook. Okay, it's what I've found students to kind of be able to use in pretty much every proof that we do completely or holistically on our own. It will get you about 90%, maybe 95% of the proof completed with very little kind of thought. Okay. Now there is quite a bit of thought in regards to that last 10 to 5% that we got to come up with. But for instance, like this, so if I was going to do this example, notice there's nothing given here, right? Nothing provided in regards to statements and reasons. Okay, we would have to do all the statements and all the reasons on our own. That's when we would direct our attention to that handout and keep that very close to it. So I want you to use it on tests, quizzes, homework, that kind of stuff. Okay, we'll go walk through what we do here. The first thing you're going to do is you're going to write down the given statement and reason one. So we're going to look at our problem. So eventually here we're going to do this proof. So we would look at the given up there at the top, says measure angle 1 equals measure angle 3. All right. Then that becomes statement 1 and it becomes reason 1. Reason 1 is given. It was provided for me. That's the only, I got to start with something, right? Okay. To build any type of structure, you have to start with something. We have to be provided with something. That's what we're provided with. Okay. The second thing says, if there is information regarding equal incongruency signs, fill that information into your picture. So statement 2, or step 2 here, is directly linked to step 1. If in my given there were equal signs or congruency symbols, I need to go to my picture and I need to draw that stuff in. Okay? So I would go to angle 1, draw an arc in there, go to angle 3, draw an arc in there, and that's going to help me, as we progress through this question, make more decisions. All right. Especially when the questions get a lot more complex than this one, if I don't put things in my picture, I'm not going to be able to look at my picture and see what I'm missing or what I need to incorporate yet. So it's a very, very important step. Step 3 then says you're going to look at your given information, see if there's any vocabulary words. Okay? Because we're trying to find out things that we know to be absolutely true for the problem that we're dealing with or the situation that we're dealing with. Obviously, the given has to be absolutely true. And then if there's vocabulary words, the vocabulary words will provide me things that I know to be absolutely true. For instance, if there's a vocabulary word of midpoint in my problem, okay, what do midpoints provide you? What do they do to a segment? Split it into 2 equal parts, right? So if you see the word midpoint written in your given, that tells you, for your particular problem, you know without any doubt that there should be 2 segments that are congruent. You're going to want to write that down. You're going to write down what that midpoint provides you in your specific problem. Okay. So I give you kind of an example of what I mean by that right here. See how this given here says C is the midpoint of AD? Okay. So they wrote their given down first, right? And now the author went through it. Okay, well, there's a midpoint definition right here. Okay, and it's specific to this question. So if I come over here, if C is the midpoint, doesn't that mean that AC is congruent with CD? And that's what they write right here, correct? Okay, so they write the specific congruency that definition, that vocabulary word, provided us for our situation. Okay. The next thing I would do once I write that statement down, 99% of the time, my reason over here will be because of the definition of where that vocabulary word was. Okay. How did I know I got 2 congruent segments? Because in the glossary, if I look at midpoint, it says it is a point that divides a segment into 2 equal parts. Okay. So you would write definition of midpoint, or you could write out the idea that it is. You can write out the phrase, it is a point that divides a segment into 2 equal congruent parts. Okay. Usually people prefer to write something shorter. The definition of midpoint is what we're looking for there. So you do that, okay? And you do that with every vocabulary word that you may see key in your given. So if you see 2 vocabulary words, you got to do that twice. You see 3, you got to do it 3 times. Okay? And what happens is you're actually benefited if there's more vocabulary words. If there's 3, 4, 5 vocabulary words, that makes things a lot easier because you've now figured out a lot of true things about your picture, and it might be easier for you to start kind of sandwiching or compressing some of those together to get new facts. All right? You're going to do that step 3. So step 3, a lot of times, like words like midpoint, angle bisector, segment bisectors, those are vocabulary words that provide congruencies, right? So once I write a congruency down like they did in that example, it said AC was congruent to CD or CB. Once you do that, you want to go to your picture and draw that in your picture. All right? So statement 4, or step 4 here, is just like step 2 was, right? You write a congruency down, always draw that back in your picture. All right? So steps 1 and 2 are kind of partnered up. Steps 3 and 4 are partnered up. Okay? And in each of those, step 2 and step 4 are kind of the same thing. Okay? That gets us to step 5. Okay? Step 5 is going to, there's actually 2 aspects of step 5. It says look at your picture. Okay? This is going to kind of help us direct the next couple of steps. If my picture deals with angles, then it's likely that I'm going to use angle addition. Okay? And that's going to be the kind of the governing principle that guides the rest of the proof, is adding angles together. If it's segment, then I'm probably going to use segment addition. And that's going to be the governing process that progresses the proof. Okay? Later on, we'll deal with parallel lines, and that will be chapter 3. Okay? So we'll look at our picture. Are there parallel lines? Then that idea will kind of progress the question. Does that make sense? If I see parallel lines, it's probably not going to use angle addition. If I see parallel lines, I'm probably not going to use segment addition. If I see triangles, I'm probably not going to use parallel lines. Does that kind of make sense? So it allows us kind of collectively, as we start learning more and more information, say we're in chapter 7, we've got 6 chapters of information, okay? If I see triangles, basically in my proof, that basically tells me that in chapter 7, I can eliminate 6 chapters of information that I know and focus just on the triangle stuff. Does that make sense? So it kind of puts blinders on you or narrows your focus if you're able to look at your picture and realize what is it a picture of, okay? Another part of that I don't think I had written in there, if you ever see anything being shared, okay, like an angle being shared or a segment being shared by multiple angles or multiple segments, that's something that we're going to look at. We're going to pay attention to that. All right, we'll see that in our first example here today. If you could do steps 1 through 5, guys, and you can write that information down, that's 90% of your proof. That's going to be a good bulk. So if your questions were 10 points, you got 9 of them from that. Okay, maybe 8 of them from that. Step 6 is where people a lot of times go astray. Okay, step 6 says you are to look at several statements that you've had previously made. Okay, and you're going to link them together and see if you can make up anything new. Okay, so link them together and see if you can come up with anything new. That is the law of detachment, law of syllogism that we talked about last couple of days. Okay, we'll take 2, 3, 4 statements and see if combining them leads me to a new fact that I know is absolutely true because the things they combined were true. Okay, if we can do that one time, hopefully that one time, especially early on, that one time we do that, that new statement will match up to what we wanted to prove. Okay, and that leads us to step 7. If that matches up to what you wanted to prove, then you're done. Okay, if it doesn't match to what you wanted to prove, you do step 6 again. You keep doing step 6 again until you piece it all together, you get all these facts that are true, and eventually it will lead you to a statement that matches exactly what they asked you to prove. And then that's the identifier that tells you you're done. Okay? So we're going to do an example of this, guys. And, do a couple examples throughout the next couple of days. But what I want you guys to understand, especially early on, when they provide some of this stuff for us, just like any other writing, like if I ask you guys to write a biography about Abraham Lincoln, okay? I asked 15 of you to do that. Or am I going to get 15 different papers? 15 different types of writing, correct? Okay, you all have a little bit different style than what everybody else has, okay? But within those 15 different styles, should everybody have the same birth date? Should everybody have the same location that he was born in? Should everybody have the same date that he was assassinated? Same dates and times in which he was the president, okay? We should have all those things, right? Okay? So there's going to be facts, even though everybody's paper is different, there's going to be facts within everybody's papers that are consistent, okay? That's the thing. That's what we want to talk about in proof. Okay? You might make a proof that's completely different than your neighbors in the way we maybe organize some of our steps. Maybe you have 10 steps, your neighbor has 7 steps. But if we have inside our 10 steps enough information to make a valid conclusion, then we're fine. Okay? Your paper might be 4 pages, your neighbor's might be 7 pages, right? But if we've all got the same facts, we should be probably okay. One thing I want you to understand is that when they walk you through a proof like they're doing here with the statement, this author has probably already done this proof once, okay? Knows what the key components of the proof are, knows that, okay, if this was my rough draft, let's reorganize things a little bit, make it a little bit more finalized, make it a little bit cleaner looking. So they may have kind of adjusted, after they've done the proof one time, adjusted things so that it becomes a little bit cleaner and better looking. Does that make sense? Like you would do in a final draft, right? You would delete sentences out, replace them, and move them around, that kind of stuff. So what I'm trying to argue here is that when they guide you, their guidance might not match up to the 7 steps I gave you on that handout. Okay? They should be roughly about the same, but they might skip over a step, or they might go down to like step 6, and then come back up to 5. And we'll talk about why we can do that later on. Okay? It's we'll call it a dependency idea. Okay? But once we start getting comfortable building these proofs, we'll take some time, set aside, and say, okay, now we can build them, we understand what they're doing for us. Let's see how we can restructure them, okay, and still be okay with the results. I want to show you with this one. So I got you guys, I give you time. Hopefully you're writing this down. But really, right now, all I want you guys to do is write down what's in that gray box, okay? Write the given and the proof, and then draw that picture down. I'll give you a couple minutes to do that. And then we're going to walk through kind of a discussion of the purpose of these proofs, and why we're going to do them, and why they're going to look the way they do. As you're writing, I just want to talk to you. There's going to be kind of with everything in this class, everybody's going to be kind of different level with this, okay? Some people are going to master this day one, okay? Some people aren't going to master this until they're juniors, okay, or maybe seniors, okay? When I was in school, I didn't really grasp this stuff. I could do it, but I really didn't understand what I was doing, okay? And it kind of led me to those 7 steps and developing those 7 steps to help myself. But I didn't really understand the purpose or the logic of this stuff until I was older. I was more mature and had a little bit more math under my belt, okay? So there will be people like that, okay? Now, it's just like anything else. If you're not good at these and you give up on them right away, you don't expose yourself to them, and you don't go use external resources and ask for help and participate, are you ever going to get good at them? No, okay? So obviously we're going to have people who are really good at them, people who are really bad at them. But everybody, as we go through this process, everybody should increase their skills somehow, okay? And increase their proficiency within them. I'll put proofs on quizzes and tests and stuff like that. My main task for you is to develop an understanding of why we're doing this. All right. A lot of the things that I do with you guys is because of how I was taught, and in regards to that, I didn't like the way I was taught. It was kind of a sink or swim mentality for some of my teachers. Okay, I had Mrs. Coles. Mrs. Coles was awesome, and if I ever had a question, it was help was provided, right? Okay, you guys have experienced how she teaches. She would help whenever you needed it, okay? And she explained things very well. I had other teachers that were brilliant people, okay? They're really good teachers in all actuality. And if I look back now, without them, I would not be where I'm at now. But it was a sink or swim type thing. You've been in classes like this where here's the information, you deal with it. I'm going to distribute it to you. You learn it on your own and then perform on your own. Does that make sense? I hated that, okay? But I wanted to have good grades. So I busted my butt in researching and asking questions and using my sister to help me because she had already experienced all that stuff and developed a proficiency within those things by teaching myself. I hated that. It was a miserable couple of years in those courses. I don't want people to feel that way, okay? So I don't think you need to feel that way. It is good to experience, I think, sometimes, because then it gives you an appreciation for when you're not experiencing that. But that's why we're going to do some proofs. It's going to be maybe kind of monotonous sometimes because we're going to talk things out. We're going to discuss things. But the reason I do that is I don't want to give it to you on your own and say, have at it, okay? Because some people are going to be like swimming with cinder blocks on your feet, okay? It's going to be hard, all right? So that's kind of the approach that I take. Is that all right with everybody? Okay. You've all been in that situation. My teachers were so smart. Okay, I had a chemistry teacher this way, and she would help a lot though. She's very, very, very smart. And my geometry and pre-calculus teacher, he was a genius. But you've all been in a situation where you've had a teacher that was just so much smarter than you and understood the information at a such higher level than you that when they tried to explain it, it was just so simple to them that they had trouble explaining it, right? You guys experienced that before? Okay, so you experienced that. It's not to their fault because it just comes natural to them. This did not come natural to me, so I have kind of empathy. I understand your position with some of this stuff eventually, okay? So if you ever have questions, please do not hesitate to come ask me, see how we can deal with this stuff, how we can work things out. But we're going to go at a slow pace, and we're going to deal with these a lot because, one, it's an in-course exam criteria, but two, it's going to help you navigate the rest of math, not just this class, but other courses, okay? And here's the idea. If I look at this problem, okay, we're going to do this with the specific values first, because it's really easy with specific values. But then we're kind of trying to show you why that's not enough for us to say that this is a proof, okay? So let's say, right here, they're saying you start off with that known information. You know angle 1 is equal to angle 3. So somebody give me a number. 7, okay? So we've got this angle here to be 7 degrees, that angle there to be 7 degrees, okay? Would that be a specific situation where angle 1 is equal to angle 3, right? Give me another number. What did you say? 47? I'll say angle 2 is 47 degrees. Would you guys agree that based on those values, that angle right there is going to be 54 degrees? Okay? Would you also agree that angle right there is 54 degrees? And if you look at what we're trying to prove, this one here, AEC, that's the red angle. Right here, that's the blue angle, right? Okay? So we just showed a specific case scenario. If you start with angle 1 and angle 3 being equal, when we add some other number like 47 to both those, we still get something to be true, right? But that's just the case for those two numbers, 7 and 47. We would then, if we wanted to prove this to be always true, remember, proving something to always be true, there have to be no counterexamples, right? What we would have to do is go through all the other numbers that exist. How many numbers exist? A lot. That's a better word for that. Infinite, right? There's an infinite number, value, or a set of numbers that we have to look at here to see if that relationship exists for every single pairing of those infinite numbers, right? So essentially, think about this. I'd have to go like 7 and 47 and see, do I get 54? And then I try 7.1 and 47. In both of them, do I get 54.1 as a sum? And they go 7.11 or 7.101 or 7.10201. You can start to see all the infinite number of combinations just for 7 that I would have to check. Is that going to be impossible? Yeah, okay, because we'll never be able to write all those values out for both those angles. So showing with specific examples, you might get an idea of what you need to do, but you're not going to have enough validity to prove that this is always going to work, because when I use specifics, there might be one out there. There might be a counterexample hiding out there that I didn't check. Does that make sense? So our proof process is going to eliminate that potential of a counterexample kind of lingering on the outskirts that we weren't paying attention to or that we didn't know was there. Okay? And basically the way we approach that is say, even though we're going to treat things like numbers, we're not going to use numbers. Okay? We're not going to use a value like 7. We're going to use a symbol that represents a value like 7. Measure of angle 1 there in statement 1 is a number, right? But that's a symbol for some number that I don't know what it is. Okay? But I know it's equal to the symbol that is representing some number, angle 3, or the measure of angle 3. Does that make sense to everybody? Okay? So these are symbols here that represent all of these infinite values of 7, 7.1, 7.01, 8.2, whatever. Okay? These are symbols that represent all those infinite values. Is that okay with everybody? Okay? And if we can maintain that understanding, that idea as we progress through here, we should be able to kind of prove, regardless of what I start with, whether I start with 7 or 7.1 or just the symbol, measure of angle 1 that represents the number, I can prove then that that conclusion, that angle AEC and angle DEB are indeed the same no matter what I start with. Okay? So we're going to go through that process and kind of looking back to that handout I gave you to kind of help with this. Because the author does somewhat of a good job of keeping pace with those 7 steps. Okay? First one is to write down our given. Okay? So that's our given information. We have to start with something. Okay? So that's given. That's the if part of some true conditional. And really what would happen, guys, if I asked you to write this as a conditional statement, you'd really say if measure of angle 1 equals measure of angle 3, then measure of angle AEC equals measure of angle DEB, right? That's the if-then statement that our proven or given came from. I'm sorry. Capital I. No. Once we write our given down, that step 2 in that handout said you're going to look and see if there's any equality or congruency. Okay? Did they come out right in front of me, tell me, did they use an equal sign or a congruent sign in here? And they did, right? Okay? I'm going to go up into my picture. I kind of already drew it in here for you. I'm going to draw on that picture and remind myself that angle 1 is congruent to angle 3. Okay? Because think about this. If I didn't do that, and I go down and I work step 2, step 3, step 4, when I look back at my picture, I didn't draw anything in there, I can't remind myself what angles were congruent. The only way I can remind myself is to go back to all my statements and read through all my statements, right? If I look at my picture, I instantly know what things are congruent, right? Instead of having to decipher all my statements on the left-hand side. So adding things to your picture is very useful. All right, so that gets us to statement 3, or step 3 in that handout. And it says vocabulary, right? Look for vocab words. Any vocab words in that given? No, so that's awesome, because if there's no vocab word, it's kind of a double-edged sword. We want a vocabulary word because it's going to lead us to new facts. But at the same time, maybe we don't want them because it's going to get us through those steps a little faster, right? We can skip step 3 because there's no vocabulary word, which means skip step 4 because that's attached to the vocabulary word step. So it gets us to step 5. And now here the author kind of jumps back and forth between step 5 and step 6, okay, in the next couple statements. Step 5 says to look at your picture. All right, and we read that statement, and I talk about if your picture is angled, then what are you probably going to use? Angle addition. Okay? If it were segments, we use segment addition. Right now, that's all we know. That's all we've dealt with so far in this course. In regards to actual geometry stuff, instead of, we've been dealing with a lot of how to read things and structure of sentences and stuff like that. But dealing with just some real pure geometry, we've basically been able to talk about how we can take angle 1 and angle 2 and add those together to get angle AEC. Take angle 2 and angle 3, add those together to get angle DED and that kind of stuff. Okay? So we put that in the back of our mind. We're probably going to use angle addition to progress through the rest of this proof. Another thing we want to do every time we look at our picture is to think about, okay, our goal is to look at AEC and DEB and prove those angles congruent or equal. Would you guys make the argument, would you agree with me if I said that angle right there, with inside that green angle is all of angle 2? Do you agree with that? Would you agree that, let me, let me do this. Looking for colors that will change when I overlap them. Yellow and blue will work. What? Yeah. So we can agree that angle 2, all of it is inside that yellow angle. And angle 2 is all inside that blue angle, right? And when it changes to green, it shows you that the green was the overlap, right? If you ever see overlap like that, you might need it. And I say might, probably 90% of the time you're going to need it. Okay? So those are 2 things that looking at our picture we're going to deal with. And those are things that obviously right away, and I told you look at the picture and tell me what you know, those probably weren't that. You probably got to be shown that that's a kind of a pattern or a behavior that we're looking for. Does that kind of make sense? Okay? So I'm not assuming that you knew that right off the bat that we're going to need those things. And early on, I'm not going to make that assumption that you know that we're going to need those things. But after we see, a dozen of these questions, 2 dozen of these questions where we're using those types of concepts, I hope that training of seeing example after example tells you, hey, I'm probably going to need that angle too. Okay, talk about it somehow. So here's the thing. They write at statement number 2 here, they write measure of angle 2 equals measure of angle 2. You remember yesterday what property that is? Yeah, that's the reflexive property. Huh? Right up here, it's dotted. You just can't see it. I'm given. Yeah. All right, so we got the reflexive property of equality. Okay. Now I know, at least this is the way I thought when I was in school. It's kind of stupid to say something's equal to itself, I think. But the reason we do that is because it's going to be used in the next step, or maybe the second step after that. Okay. Shortly after I write measure of angle 2 equals measure of angle 2, I'm going to see the purpose of why we did that. Okay. If you guys look at number 3 here, okay, would you guys agree that if I highlight that right there and that right there, that is exactly the same thing as that? Is that okay with everybody? So I'm going to tell you that statement 3 is just like statement 1, except for what did I do to both sides? Put on measure of angle 2 on both. So and remember, measure of angle 2 is some number, right? Makes sense, everybody? It's a symbol for a number. I don't know what that number is. Okay, maybe it was the 47 you gave me, but maybe it's also 12. Who knows? Okay, but it's a number. If I start with 2 things, these 2 yellow things that were equal, and I add the same thing to both sides, is that legal to do? What property tells me that that's something we can do? Addition property of equality. So this is, again, these reasons are the why, or this is because I can do this step 3 because of that property. Okay? So kind of going off, ask mom and dad for the car this weekend, they say no, and I want to know why. So they say because you didn't do your chores this week, something like that. So this is that group of reasons that support the work that we do over here. Okay. So now, that's kind of a situation right there where we've used 2 previous lines, 2 previous pieces of information to create something new, right? Okay. That's the law of syllogism there. Okay. Using 2 previous facts to come to to merge together to come up with something new. Okay. And now because these were true, this is true. Okay. Now step 4 is kind of looking back at the picture. Okay. Think about what they're doing here in step 4. They're saying if I add angle 1 to angle 2, that should give us that angle AEC, right? But when I add 2 smaller angles that are adjacent to get the larger total, what do we call that back a couple weeks ago? What did we put in the back of our mind off of step 5 when we read our handout? We put in the back of our mind that what process is probably going to govern this question? Angle addition, right? Adding angle 1 and 2 together, right here, 1 plus 2 equals AEC, that's angle addition. Okay. Now, can I say the same thing about 3 and 2? If I look at angle 2, add that to angle 3, does that give me that entire angle BED? Yeah. So that's why these two things are written kind of under the same number 4, and then we only need that one reason for both angle addition. Both these statements are angle addition. All right? So those steps, guys, those 4 steps are the idea that if we go off of that handout I gave you, follow that handout, you could probably come up with the majority of those 4 steps from that handout. Okay? And especially if we see more and more of these and start working with more of these, those 4 steps will become pretty easy to see. Okay? Just because of the patterns that these things take. Now here's my question, or this is what I'm going to tell you. I'm going to tell you that this statement right here, statement number 5, you have already made it somewhere else. You have already said this somewhere else. Where? 3. You said it in 3. Okay? So statement 3, guys, says that 1 plus 2 is equal to 3 plus 2, right? Well, if I write in number 4, that says 1 plus 2, which is that thing right there, right? Isn't that the same thing as AEC? So let's take, so what we're doing here in step 5 is we're going to take that, when I put that box around, and we'll replace with what it's equal to. So we'll put AEC there. Okay? And then this box here, isn't that what we're seeing down here? So we're replacing that box with DED. When I replace those things, we get this statement here, right? What's that idea of pulling 1 plus 2 out and putting in with what it's equal to is substitution. Step 5 is substitution. Okay? Now here's the thing, guys. Proofs, they're not, the next proof we come across might be a little bit different than that. So there's not, you know, like when we factor things in algebra, a set, do this first, do this second, do this third. Okay? With proofs, it varies. Now that paper I gave you is going to be somewhat of a guide for you. Okay? What we do need to understand is that when we do one proof, try to learn the mechanics of that proof, because there's going to be patterns that existed in there that are going to exist elsewhere. If we come across another proof, guys, that deals with angle addition, there's probably going to be 2 steps in there like 3 and 4. And there's actually going to be 3 steps in there like 3, 4, and 5. So there's going to be clusters of statements that we can use elsewhere in other proofs that are very similar.
Pardon the interruption for an afternoon announcement. The tailgate scheduled for tonight has been canceled due to expected rain this afternoon and evening. The tailgate will be moved to Monday,